In this video, we're going to tackle some more advanced problems involving exponents, laws of exponents. And for these ones, you're going to see I'll be taking multiple steps here. There are a lot of different ways to do many of these problems, so what you're going to see here is not the only way. However, if you've done everything correctly, you should come up with the same answer no matter which way you do them. Okay. So this looks pretty complicated here, but we're going to go ahead and just tackle it one piece at a time. So the thing that I usually tackle first would be negative exponents and exponents on the outside of parentheses. In this case, let's go ahead and deal with the negative exponents. Actually, to start off with, it may be well served to go ahead and put exponents of 1 on anything that don't currently have exponents. So, okay, that's taken care of. Let's go ahead and take care of, we've got a x to the negative 2 here, we've got an x to the negative 3 here. So I'm going to rewrite this first product here as y over x squared. That'd be y to the first over x squared. That x squared moved down because it was a negative exponent. My second product here, I've got a 2 to the first, it's going to stay up top. A y to the third is going to stay up top. And this x cubed is going to move down to the bottom because of that negative exponent as well. The last part of this, we can, well, let's go ahead and take care of it because we do have a power on the outside. And we know that if it's a power to a power, that we need to multiply our exponents. So everything on the inside of there, all the exponents are going to have to get multiplied by 3. We're going to end up with an x to the 9th and a y to the 9th. Now that's not currently a fraction, but we can make it a fraction. We can always make something into a fraction by putting it over top of 1. So I'm going to go ahead and do that now. All right, so I've got 3 fractions in my next step, and I'm going to just go ahead and start reducing this down a little bit. What I think I'll do is I'll start by multiplying across the top and across the bottom, and that'll turn this into a single fraction. So let's go ahead and multiply across the top. I'm looking at the coefficients, and the only coefficient I see is a coefficient of 2, so I've got nothing to multiply coefficient-wise. Next, I'm looking at the x's on the tops of my fractions, and the only x I see on the top of my fractions is that x to the 9th. There's nothing to multiply that guy by either. So I'll just go ahead and bring him in there. We do have several y's going on the top here. We've got a y to the first, a y to the third, and a y to the 9th, and those are all going to get multiplied together. And when we multiply together things with the same base, then we add the fractions. So we'll be adding 1 plus 3 plus 9, and get y to the 13th. On the bottom, we're multiplying x squared, x cubed, and a 1. And 1's not really going to do anything, so I'll just kind of ignore that. However, we've got x squared and x to the third. Since we're multiplying, we should add the exponents. That's going to give us an x to the 5th. All right, now I've got everything into one fraction, and we'll look to see if we can simplify anything. I'm envisioning with the x's, we've got x's on the top and x's on the bottom. There's 9 x's being multiplied across the top and 5 on the bottom. And we should be able to cancel a bunch of x's. We should be able to cancel 5 out on the top with all 5 of them on the bottom. That's going to leave us with 4 x's on the top and none left over on the bottom. 2 has nothing to reduce or cancel with, and the y to the 13th has nothing to reduce or cancel with. There's nothing really left on the bottom, so we could put this fraction over 1, or we could just not write it as a fraction at all. At this point, there are no like bases that we can combine. There's nothing to reduce. We've taken care of all the negative exponents, so this is going to be our final answer.
Please excuse the interruption. Any students who are writing?
Okay, our next example here, we've got fractions to begin with. We've got parentheses. I think I'll probably start this one by dealing with the parentheses and see where we can go from there. So inside of this parentheses, I've got a 2 to the first, x to the first, and a y to the first. And those exponents are all going to need to be multiplied by the exponent on the outside. So we're going to end up with 2 to the second, x to the second, and y to the second on the top of this fraction. We've also got a y to the second down here. All right, no more parentheses. I'd probably be looking to cancel. I do see a y squared and a y squared. And since those match up perfectly, we can just go ahead and cancel those. So not a whole lot left going on here. We got 2 squared, which is 4, and we've got an x squared. Nothing else really to simplify there, so that's going to be it for us, 4x squared. All right, next up, I'm seeing, again, parentheses with exponents on the outside. I'm probably going to go ahead and take care of that first. I don't see any negative exponents to deal with right now. So let's take care of this, this first part of this. We got a 3 to the first and an a to the third on the inside. Those exponents need to be multiplied by that 2 that's on the outside. So that'll become a 3 squared and an a to the sixth. And that a to the third, I'll just take it down, and we'll deal with that in the next step. So we are multiplying out an a to the sixth and an a to the third. When we multiply, we should be adding the exponents. That's going to become a to the ninth. And then that 3 squared, let's just go ahead and call that a 9, and then we'll be done with this one. So pretty quick, simple problem there. All right, this time we've got a fraction inside of parentheses with the power going on the outside. So I'm going to start this off by applying an exponent of 1 to anything that didn't have it written. And next thing I'm going to do is deal with this exponent on the outside. Let's get rid of these parentheses. So that 2 gets applied to everything inside the parentheses. And the rule is that the 2 gets multiplied by any of the exponents that are present on the inside. So we're going to have on the inside, we had an x to the third. Take that 3, multiply it by 2, and you get x to the sixth. On the bottom down here, we have 2 to the first. 1 times 2 is 2. We started with an x squared. We'll multiply that by 2. We'll get x to the fourth. We got a y to the third. Multiplied by 2 is going to give us 6. We got a 3 to the first. 1 times 2 is 2. We got an x to the third. 3 times 2 is 6. Okay, from here, we've got several options for what we're going to do next. I do notice that I have an x to the sixth on the top and on the bottom. So we could, right now, just go ahead and cancel those. And we'd have nothing left on the top. Of course, we'd want to leave a 1 up there. And, well, let's just go ahead and bring this down to the next step. That simplifies it quite a bit. We've got 1 over 2 squared. You know what, I'm going to go ahead and call that 4. We've got x to the fourth and y to the sixth and 3 squared, which is 9. The x to the fourth and the y to the sixth are going to have to stay as they are. We don't have any negative exponents to move them around, and the bases aren't the same, so we can't add their exponents. About the only thing we have going for us right now is we've got this 4 and this 9, and those two things are being multiplied. We can switch the order of multiplication and multiply in any order we want. So if we wanted to multiply them together first, we could. So let's go and do that. We'll call it a 36 out in front. We still got that x to the fourth and y to the sixth in there. And at this point, I think we're done. There's nothing really else that we can do with that fraction. So that's it. Okay, one last one. We got fractions, we got negative exponents, we've got an exponent of 0. We've got a lot of stuff going on here that we're going to have to deal with. People often ask, how do you know what to do first? And the answer to that is, I don't. You can do whatever you like first. Just make sure that you're not breaking any of the rules. So one thing that I cannot do, that I've seen people do in the past, cannot cancel these x squareds. Reason being is that the one on the bottom does not have any other exponents applied to it. The one on the top is being applied an exponent of 3. So probably that's where I would start. I'm going to probably get rid of those parentheses on the top first and take this 3 that's out here and go ahead and apply it to everything in there. So that means I should be multiplying by each of these exponents in here. So I'm going to have a 3 to the third, an x to the, 0 times 3 is still 0. We'll have a y to the sixth, and I'm just going to copy everything down on the bottom. I don't want to bite off too much in one step because I'll make a mistake. All right, x to the 0th power, we know that that's equal to 1, so I'm just going to go ahead and cross that out. Multiplying by 1 and not multiplying by 1, nothing's really changing there, so really the top's just 3 cubed times y to the 6th. What else would I tackle here? Probably in this step, I would probably also start to look at that negative exponent on here. We could go ahead and take that x to the -2. We could move that up to the top of the fraction. And yeah, let's go ahead and do that. So that'd probably be my next step. Leave everything else where it is. 3 cubed. Let's move this x squared up to the top. We still have a y to the 6th up here. On the bottom, we've got a 3. We've got a y squared. We've got a 2y cubed also. All right. What to do next? Looking at the top, there's nothing really to do except to take care of this 3 to the 3rd power. That is 3 times 3 times 3, which is 27. We've got a y squared and a y to the 6th up here. On the bottom, there is a 3. There's a 3 and a 2, so we can go ahead and multiply this 3 and this 2 together. We are multiplying everything together on the bottom, so we can go ahead and take care of that first. They give us a 6. We also have a y squared and a y to the 3rd that are being multiplied together. In this case, since the same base is being multiplied, we should add their exponents. That become a y to the 5th. Okay, and moving on to a new step here, I'd probably be looking at this 27 over 6. Those are both divisible by 3, so we should be able to reduce that fraction. Dividing by 3 on the top and bottom is going to give us a 9 on the top and a 2 on the bottom. Got that x squared, nothing much to do with that. However, we do have a y to the 6th on the top, a y to the 5th on the bottom, so we should be able to cancel some y's. All 5 of those y's on the bottom are going to cancel with some y's up top, and it's only going to leave one y left over on the top. Looking at that last step there, is there anything to reduce, cancel, combine together? And I'm not seeing anything, so that's going to be our final answer for that one. Okay, so some more advanced examples there. Again, just please be very careful and take as many steps as you need to. If it takes you 12 steps to get through a problem, you'll be happy that you took the steps because you'll get it right. All right, thank you so much.